Okay, in this video, we are going to look at finding the local maxima and minima of a function, finding out where a function is increasing and decreasing using the first derivative, as well as using the second derivative to find inflection points, regions of concavity, and so on. So that is the goal of this video. So this is section 4.3 of the textbook. And look at the first question in here. The question asks you to sketch a graph. Now, each of us can have a different answer. So I'm just going to see what it is that I can come up with. So these are the conditions to be met. The conditions are that f of 0 is 0. That means 0, 0 is a point. F of 4 is also 0. So that means this is another point. Then f prime of 0 is 0. So what it means is that at this 0, 0, your function is going to have a horizontal tangent, right? So basically, your function can go like this or it can go like that. So keep that in mind. Likewise, f prime of 2. So here also, you're going to have a horizontal tangent at f prime of 2. So then it also tells you that f of x is greater than or equal to 0 in the entire negative infinity to positive infinity. That means the entire graph is above the x-axis. So based on all of this, this is what I'm going to come up with. So my graph is going to have a horizontal tangent here, another horizontal tangent here, another horizontal tangent here, and this is satisfies all the given criteria, right? And this is a potential function, graph of a function. All right, moving on to the next question. A second derivative of a function is given to you. The question is asking you on what intervals is g concave up, concave down. So to do that, what you can do it multiple ways in here. So let me show you two ways. Now, how does the graph of g double prime look like? Now, it's a very simple linear function, isn't it? So the linear function is going to be like this. So this is 2 minus x, right? So that's what it is. And this intercept here is going to be 2, right? So based on that, what do you see? So suppose if you had a number line, you're going to have 2 here, right? 2 is a critical value for the second derivative. So all the values of x from negative infinity to 2, you can see that the graph is above the x-axis. That means g double prime is positive in this interval and it is negative in this interval. When g double prime is positive, g is concave up in that interval and concave down in this interval 2 to infinity. And this point where the concavity changes is called the inflection point. So where is my inflection point? It's at 2 and whatever the function value is, right? So but x equals 2 is a critical value for the inflection point. All right, in this, the second derivative of a function is given. For what values of x in the interval negative 4 to 3 is the graph concave up and where is it concave down? Now, this is the second derivative, right? So this is the graph of the second derivative. They want you to restrict all your answers between negative 4 and positive 3. So in this interval, so this is the interval that they want you to look at, okay? So in this interval, what do you see? You see that the second derivative has a value of 0 here. It has a value of 0 here, and it has a value of 0 here, correct? So those are all your inflection points. So the all of those zeros. So inflection points will be at x equals negative 3, 0, and 2. Okay. So now, if you see in this interval, right, from the interval negative 3 to 0, So you see that G double prime is greater than 0 in which interval from -3 to 0 as well as 2 to 3, right? So that means the graph of G is concave up in this interval. So likewise, G double prime is less than 0 between -4 to -3 and 0 to 2. So that means G is going to be concave down in that interval. Okay. Okay. Next one. The question is asking you to find the intervals where f is increasing and decreasing. Okay. So to do that, we are going to do the following. So the graph is restricted in the domain 0 to 2 pi. Okay, keep that in mind. So I take the first derivative. The first derivative will be 2 sine x minus 1, correct? Okay, then I set the first derivative equal to 0 because this is never going to become undefined. So I solve for this. Sin x equals 1/2. That means what are all the values between 0 to 2 pi when sin x is 1/2? In the first quadrant, it is pi over 6. In the second quadrant, it is 5 pi over 6. So these are the two critical values for me, right? So now I need to find out where the function is increasing and decreasing, right? So you can do it several ways, but let's do this. So I'm going to, this is 0, this is 2 pi, this is the restricted domain, and I have pi over 6 here, 5 pi over 6 here, okay? So that means 0 to pi over 6 is here. Pi over 6 to 5 pi over 6 is here. And 5 pi over 6 to 2 pi is here. Okay. Now, what I'm going to determine now is I'm going to take a test point in each of these intervals. So 0 to pi over 6. Well, that's pretty tricky, isn't it? Like, to find a unit circle value, I mean. But okay, I can take anything I want. Let's say I just take pi over 12, just like that, okay? Because I don't know some things about this. Okay. Then I'm going to do between pi over 6 and 5 pi over 6. The easiest one to take would be pi over 2. And 5 pi over 6 to 2 pi. Oh, that's a big one. 5 pi over 6 to 2 pi. So I can even take 3 pi over 2. Okay. So then I'm going to find the sign of f prime. Okay. So when I put pi over 12, okay, 2 times sine pi over 12. You know that sine pi over 6 is 1/2, which means pi over 12 is less than 1/2, right? Which means 2 sine value of pi over 12 minus 1 is going to be a negative number. Then I put pi over 2. So sine pi over 2 is 1. So 2 minus 1 is 1. So that is positive. 3 pi over 2. Sine 3 pi over 2 is negative 1. So negative 2 minus 1 is negative 3. That is negative. So what is now happening? I am going to have a sign change. My function, my behavior of f, if you look at it, f is decreasing here, increasing here, and decreasing here. So it is decreasing, increasing, decreasing. So that means this is going to be a local minimum and this is going to be a local maximum, but that's not what the question asked us. So what we are going to answer is that the function is decreasing in the intervals 0 to pi over 6 and 5 pi over 6 to 2 pi. And it is increasing in the interval pi over 6 to 5 pi over 6. You can always check this with a graph. So the graph, the original function is -2 cosine x minus x, -2 cosine x minus x, -2 cosine x minus x. So if you look at this, you're going to see that so our interval was 0 to 2 pi, correct? So in 0 to 2 pi, you see that the function is, as we said, was, so it was from 0 to pi over 6, it is decreasing. Pi over 6 to 5 pi over 6, it was increasing. And then from 5 pi over 6 to 2 pi, it is decreasing. So it matches with what we found. All right, so now let's go to the next problem. So here you have this function, and again, you're supposed to find out in which interval the function is increasing and where it is decreasing. So again, I'm going to take f prime. Now, before that, for this problem, let me just see what the domain is. So the domain of this function is um, -3 to 3 anyway. So that is the domain of this function. So, okay, so that's a domain. Anyway, I'm going to take the derivative. So here I'm going to use the product rule. So first I'm going to keep x squared as is. I'm going to take the derivative of that 1 over 2 square root of this times -2x plus square root of 9 minus x squared times 2x. The 2 and the 2 gets cancelled. So this can be rewritten as -x cubed over square root of 9 minus x squared plus 2x times square root of 9 minus x squared. Now, if I want to rewrite this as a single fraction, I take square root of 9 minus x squared as the common denominator. So this will become -x cubed plus 2x. I'm just writing one extra step so you can see what is happening here. So this is getting multiplied with this, okay? Which means this can be written like so. Okay, so now I distribute this and rewrite this. So to find the critical points, I'm going to set the numerator equal to 0. I already know that if I set the denominator equal to 0, I'm going to have 3 and -3, and those are not in the domain. So I'm not bothering with the denominator for this particular problem because I do know already that -3 and 3 are not in the domain of this function. So I am going to, well, actually -3 and 3, yes, are not in the domain. All right, so then I'm going to set the numerator equal to 0. Okay, so then I have this. So what are my critical values? X equals 0, and then x equals plus or minus √6. Okay, so I have these. Now I need to see which ones belong in the interval. So 0 is fine. Square root of 6 and plus or minus square root of 6 are also fine. Okay, so we have three critical values. Now I need to see which ones are going to become my for the increasing and decreasing. So what I'm going to do is I'm going to draw a number line. -3 to 3 was my original domain, correct? So -√6 is here, 0 is here, positive √6 is here. So I'm going to take a test point in all of these, okay? So here -2. So if you look at this number line here, 0 is here, -1, -2, -3 is here, right? Now, -√6 is root 6 is more than root 4, right? So negative root 6 is somewhere here, correct? So I would need something in between those two, right? Um, so let me say that I don't know what it is, but I will just say I take negative root 7, for example, right? Okay, we don't know the value, but that's what I'm going to take. So then I'm going to take here between negative root 6 and 0. I can take anything I want. I'm going to take negative 1. Here I'm going to take positive 1. And here I'm going to take root 7. Okay. And then I have to find the sign of f prime. So when I put negative root 7 in this, what happens to my numerator? Is it positive or negative? Let's see. Negative root 7. No. Negative root 7. So negative root 7 squared will become 7. Negative 7 plus 6 is negative 1. Negative times a negative is a positive. Okay. So this is a positive. If I put negative 1, what happens? Negative 1 when squared is 1, so that is a positive, negative. If I put a 1, what happens? I get a positive. If I put a root 7, what happens? Root 7 when squared is 7, negative 7 plus 6 is negative. So this becomes a negative. So then what is my behavior of f? Increasing, decreasing, increasing, decreasing. Okay. So then how do I write my answer? Where is this function increasing? You will write that the function is increasing in, so to write your answer, you're going to say f is increasing in the interval negative 3 to negative root 6 and then 0 to root 6. Whereas f decreasing, it is decreasing in the interval negative root 6 to 0 and root 6 to positive 3. And that will be your answer. All right, we're going to do the same thing for this problem again. I'm assuming these are all the same questions. Okay. All right, so again, increasing, decreasing. I take the first derivative. I will have negative 60x to the fourth power plus 300x cubed minus 240x squared. I set it equal to 0 because I don't have to worry about undefined here. This is a polynomial, so I set it equal to 0. And I take negative 60x squared as a common factor. So I have x squared minus 5x plus 4 equals 0. I factored this. I have x minus 4, x minus 1. So which means I have 3 critical points at 0, 4, and 1. So then I do the number line. The natural domain of this function is negative infinity to infinity. My critical points are at 0, 1, and 4. I take a test point. So anything less than 0, so I take negative 1, 1 half, 2, 5. Then I check the sign of f prime. The sign of f prime when x is negative 1, let's see. Okay, negative times a negative is a positive, times a negative is a negative. 1 half. Negative, negative, negative. So 3 negatives is a negative. 2, positive, negative, negative. So that is a positive. 5, positive, positive, negative. It's a negative. Okay, so behavior of f is decreasing, decreasing, increasing, and decreasing. So this is what you have. So you're going to say f is decreasing in the interval negative infinity to 0, 0 to 1, and then 4 to infinity. F is increasing in the interval 1 to 4. Okay. All right. This question is asking you to use the first derivative test to find the local maxima minima and also the absolute maximum minimum if it exists. So I'm going to take the first derivative first. I'll have 8x squared, I'm sorry, 6x squared plus 6x minus 12. Am I right? Okay. So then I set it equal to 0. So my critical points at x equals -2 and 1. Okay. Mhm. Okay, seems correct. But -2 is an endpoint, right? So keep that in mind. So that is technically not a critical value, but I'm just going to do this in, so my -2 is here, 4 is here. So we have only one value, which is 1 in here. So this is an endpoint. So we usually take the interior values as critical points. So I'm just going to use this one as my critical point here. So then I'm going to take a test point. So less than 1, but greater than -2. So what can I take? 0. And then here I take 2. Then I do the sign of f prime. Sign of f prime, if x is 0, would be positive, negative is a negative, then this is a positive, right? So that means my function is decreasing here, increasing here. So that means decreasing, increasing is a local minimum. Okay, so where is my local minimum? Local minimum is at 1 comma. I put this into the original function now. So I evaluate f of 1. What is f of 1? 2 plus 3 minus 12 plus 1. 5, 6, -6. So this is my local minimum. The question asks you also find absolute maximum minimum if they exist. So what am I going to do? I'm quickly going to put my endpoints in here, -2, 1, and then 4, and I'm going to evaluate. So what is f of -2? F of -2 will be -16 plus 12, mine plus 24 plus 1. Okay, -4, so 20, 25. And then 4. F of 4 will be 4, 16, 64, 64, 128, and then 4, 16, 48 minus 48 plus 1. So that is 129. So what do we conclude? Absolute minimum is -6 at x equals 1. Absolute maximum is 129 at x equals 4. So just letting you know that I'm doing all of these calculations in my head. And if I have made any arithmetic error, please bear with me, check your answers, but follow these for the steps. The steps are solid. I might make a mistake with the numbers here and there because I'm not checking them as I go. Okay. All right. Next question. Um, Again, we are going to use the first derivative test to find the local maxima minima and also absolute maximum minimum if it exists. Okay. All right. So the first thing is to take the first derivative. Okay. So use the product rule. So let us combine this. So I'm just going to rewrite it like this with positive exponent so you can see what's happening. So this is 2 times x minus 5 over 3x to the power of 1/3. Now, if I want to combine this all into one single denominator, what do I have to do? I have to multiply and divide this by x to the 1/3. Okay. So when I do that, this numerator becomes x plus 2 times x minus 5. I combine this 2x, so 3x minus 10 over 3 times x to the 1/3. Okay, so that's what I have. So now, where are my critical points at? If I set my numerator equal to 0, x will be 10/3. If I set my denominator equal to 0, x is 0. Now, both of them are in the domain, so I have two critical values. So then what do? I set my number line. I have -5 to 5 is the restricted domain here. So 0 is here, 10/3 is here. I take a test point. So -1, let's say, 1, let's say, and 4 here. Then I do the sign of f prime. Okay, -1 will make my numerator negative, my denominator also negative. Negative over a negative is a positive. I make 1, numerator is negative, denominator is positive, so negative. 4 will be positive, positive. Okay, so that means what is my behavior of f? Increasing, decreasing, and increasing, which means this is my local maximum and here is my local minimum, right? So the question is asking you to further go ahead and see the absolute maximum and minimum. So now I'm going to put my two endpoints here, which are -5 and 5, and then I have 0 and 10/3. I'm going to evaluate my function value. It's going to be a little tricky, right? So, let's see how best I can do it. -5. So -5 means -5 minus 5 is -10. So I'm going to use to approximate it. So -5, right? X to the 2/3, x minus 5. Okay. X to the 2/3, x minus 5. Okay. Okay, so the first one is -29. So this is approximately -29. Okay, 0. 0 is easy. 0 will be 0, right? 0 to the power of 2/3 is 0. Then 5 is also 0, right? Because 5 minus 5 is 0. So that leaves us with just 10 to the 10/3. So that is -3.7. Okay, so that tells me that my absolute minimum is going to be at x equals -5, and my absolute maximum is going to be 0 at x equals 0 and 5. Okay. Okay, so this question is asking me to graph. So, I just do something. Sorry, it's very bad drawing there. but this is just to give you an idea. So basically, they want in the interval negative infinity to 0, the first derivative and the second derivative is negative, meaning the function is decreasing and concave down. So in this interval, you see that it is decreasing and concave down. In this interval, you see it is increasing, decreasing and concave up. Okay, so now we move on to finding intervals of concavity and inflection points. Okay, concavity and inflection points. All right, so first take the first derivative, take the second derivative, set the second derivative to be equal to 0. Find the critical values in the interval 0 to pi. So in the interval 0 to pi, I have pi over 6, 5 pi over 6. Okay. So now these are my potential points of inflection. So I go ahead, I do this. I put them on a number line. I take a test point, again, like what we did before. Just do pi over 12, pi over 2, and this is still 5 pi over 6 to it's, I don't know, 5.5 pi over 6 or something like that. Okay. So then I will have to do sine of f double prime. Okay, f double prime. Where is my f double prime? Um, okay, sine pi over 12. We know that it is less than a half, right? So that means negative 4 times that. Uh, um, okay, so let's wait. So sine x is going to be less than half, right? So 4 times sine x is going to be less than 2. So that means 2 minus that is going to be positive. Okay. Sine pi over 2 is 1. So 2 minus 4 is negative. Then 5.5 pi over 6. So again, this value is going to be less than a half. So this is going to be a positive. Okay. So then what does it say about f? It says that f is concave up, concave down, concave up. So this is an inflection point, inflection point. The question is asking you for intervals of concavity and inflection points. So you will say that it is concave up in the interval 0 to pi over 6 and 5 pi over 6 to pi, concave down in the interval pi over 6 to 5 pi over 6, and then you will say inflection points at x equals pi over 6 and 5 pi over 6. So this is the same thing, all right? Okay, f prime. Maybe we should, let's see how many more questions we have. Maybe we will, so we are at 65. Okay, so taking the derivative, the first derivative, I keep the first term as is, take times the derivative of the second term, plus keep the second term as is, times the derivative of the first term. Okay. I'm going to, okay. So again, just to recall, this is just to find the intervals of concavity and inflection points. That is what we are working on. Okay. I'm just simplifying this as best as I can. Okay. So I'm going to combine this into one thing. So what I'm going to do is I'm going to take 2 times x plus 1 to the power of 3 halves as the common factor, which gives me 6 times x plus 1 plus 5 times 3x minus 4. Combine this. 6x plus 15x, 6 plus 15 is 21, plus 6 minus 20 plus 6 is minus 14. So which means 7 can go out, so that is 14. Again, I'm just hoping I didn't make any mistake. Okay, so all I did was factor out the 2 times x plus 1 to the power of 3 halves to simplify it. Now I'm going to take the second derivative. Again, keep the first term as is times the derivative of the second plus second term as is times the derivative of the first. Simplify this. Okay. Factor. So here my common factor is going to be 7 x plus 1 to the power of 1 half, which gives me 6 times x plus 1 plus 3 times 3x minus 2. Okay, so that gives me 7 times x plus 1 to the power of half, 6x plus 6 plus 9x minus 6. Is this right? Okay, must be. 7 times x plus 1 to the power of half and times 15x. So what are my critical points for this at x equals 0 and -1? Now let's see the domain. So -1 is an endpoint, which means the only critical value is 0. Then I draw my number line, -1 to infinity, right? Okay. And then I take my test point. 0 is my critical value here. So between 0 and -1, so I take -half and 1 here. Then I do the sign of f double prime. So -half, right? So that will make this negative. And if I do +1, this is positive. So which makes my f concave down to concave up, making this an inflection point. Okay. Okay. Now moving on to the last problem here. Find the critical points and use the second derivative test to find the local maximum minimum. So this is how you do this problem. You first find f prime and you have 12x cubed minus 12x squared. Now set it equal to 0 to find the critical point. Okay. So then I have two critical points, right? At x equals 0 and 1. Okay. So these are the two critical points from the first derivative test. Now, what you're going to do next is, so this is your step one. So what was your step one? You found the critical points using the first derivative, okay? Now in step two, what are you going to do? You're going to find the second derivative. So that is 36x squared minus 24x. So how do you use the second derivative test? So to use the second derivative test to find local max or min, this is what you will do. You will evaluate f double prime at the critical points you found from the first derivative test. So I'm going to first evaluate the 0. I get 0. So now, if your f double prime evaluated at the critical value is 0, it is inconclusive, meaning you cannot use the second derivative test to make a prediction, okay? You have to go back to your first derivative test to find your prediction, okay? So then you go to your number line again, and you can put your 0 in here, and you can use your test point, right? I'm just doing this very quickly. So test point, so this is, I'm going to use a test point. And I'm going to use the sign of the first derivative. First derivative is -1, meaning it's negative. And then 1/2 is also negative, right? So which means 0 is not a local max or minimum. So I used only the first derivative test. So use first derivative test to find if x equals 0 is a local max or min, okay? Because second derivative test was not possible to use. Now let's go to the next critical point, 1, right? So I evaluate f double prime of 1. What do I get? F double prime of 1. I get 36 minus 24 is 12, right? So when your second derivative at the critical point is greater than 0, what does it mean? You have a concave up and you have a critical point here. That means x equals 1 is a local minimum. So that means my local minimum is going to be at 1 comma, I put it back into my original function. I get 3 minus 4 is -1 plus 2 is 1. So 1 comma 1 is going to be a local minimum, but there was no local maximum or minimum coming from x equals 0.